So we're on June 2021, number 5. So right, let's read. Where's my pen? So they said, hold on. All right. 100 students were surveyed on the amount of money they spent on data for their cellular phones during a week. The table shows the results as well as the midpoint of each class interval, right? So that's to give you all a little reminder on what a class interval is. Your class interval will be these numbers here, the range of numbers for the amount spent. So this will be between $50 and $60. Cool? 60 to 70, 70 to 80, 80 to 90, 90 to 100. These are our class intervals. Our midpoints will be midway between 50 and 60. Everybody good there? Midway between 60 and 70. Midway between 70 and 80. Everybody good there? Right? Now, point to note. That's people still coming in. Somebody hand up. Krishma, your hand up? You have a question?
Sorry, sir. Put it on.
All right, no problem. Right, so then we have the number of students here in each class interval, right? So how many students spend between $50 and $60? 7, right? How many students spend between 80 and 90? 29, right? So everybody has a fair idea how to read the table. Cool? Right? Midpoint, once again, is midway between the class intervals. So determine the modal class, which means it's one of these classes here, for the amount of money spent. Who can remind me what modal means? What does modal mean?
The most recurring number.
The most, yeah. Right? So let's write a note on that one time. Huh? So write us note. Note. Right? So in statistics, the modal class interval, the modal class is the class interval that has the highest frequency. Okay? So your frequency for this question will be the number of students, right? So class 1, we have 50 to 60, and that will be 7 students, right? So how do we identify which modal class here is which class interval is the modal class, sorry? Which one has the most amount of students or the highest frequency? Which range? Anybody seen that?
Yeah.
How many students? Right. How many students will be in that class interval? Everybody good there? Right? Right. So your modal class is simply, you're writing it like how it is there, right? 70 less than X less than or equal to 80. Right? That's my modal class, or the class with the most amount of students in it. Who doesn't understand? Everybody good there? Disha, you good there? Modal class, right? You'll write it. You put in 5A1, part 1, write my note, put my answer. Cool? Good luck, people waiting to come in here, boy. And I'm busy teaching. Everybody good there? Ready to roll. Right. So calculate an estimate of the mean amount of money spent, giving your answer corrected 2 decimal places. All right, in red. Now we write in these definitions and these formulas over and over again in the hope that it will stick. Right? We need it to stick. So we're going to write our mean formula. They want us to find mean. So mean is going to be the summation of f, right? The f's would be the frequency multiplied by x, which would be the midpoint. Okay, so the summation of each row f multiplied by x divided by, I'm going to show you all how easy this is, divided by the summation of f, right? This would be my mean. So I'm going to put where write down my formulas every time I would put them, where f is the frequency and x is the midpoint when the question has class intervals. So if you all ever wonder why we only get probably about 5 questions done, is because I like to give notes while we actually do the questions to give you all a better understanding of what's going on, right? Okay. So hey, this symbol, I'm gonna put what this symbol means, right? So this symbol, which is like this, means summation, right? Add. We need to add. Okay, add all values. I'll put add all values. We get it? I'm going to show you how easy this is. I don't mind looking a little fancy, it's easy. So we're going to look at the table now. So let's put the amount spent, put the class intervals. You're not drawing no lines, right? All you understand what I'm saying? Amount spent, put these figures, number of students, F, put these, then put midpoint. And then I want you to put a column with F multiplied by X, right? Put a column with F multiplied by X. You all see what F is? F would be 7, 11, 31, 29, and 22. X would be 55, 65, 75, 85, and 95, right? So for each row, we're going to do F multiplied by X. Cool? So F multiplied by X, so this row would be what? Come, get all the calculators out. Let's work. Where again? 7 by 55. 7 5s. Well, 7 by 55 is 385, right? Next one. 715. 31 by 75. 29 by 85. 465. 22 by 95. 2,990. Oh, 2090. So 2090, right? Right. So we have all the numbers for our column, which is F multiplied by X. We're multiplying everybody here, right? Everybody good there? Right. Summation now. We're looking for the summation of F multiplied by X, right? That will be adding up all these bad boys here. Summation of F multiplied by X. So work on that for me. And then F, we need the summation. We need the summation of F also, which is this column. Yeah, adding up, coming out. Now, I need a few people to add this to make sure that we don't have it wrong. So add the F multiplied by X column add the F column. So I told you all it's not difficult to know. It's just look. So somebody's second 7980. 7980 would be for my F multiplied by X column, the summation of F multiplied by X. Okay, which will be you're adding all these numbers together. What is the summation of F, my F column?
100.
Talk to me there, Kyle.
100 too.
100 flat. All right, nice. Everybody good there?
Yo,
So,
number in the top this is Number in the top this is 100 students.
yeah, look, they have it up here. Oh, I didn't see that. 100 students. Very good. Right, so let's work. So we're going to find our mean, right? So mean is equal to, writing it again, summation of F multiplied by X divided by the summation of F. Write the formula over and over, please, guys. So this will be, what is 70, how much? 7980 divided by 100, which will give me 79.8. All right, you can put 79.80 if you want, it will mean the same thing. Right? So this will be the mean. They set to 2 decimal places, but it's already to 2 decimal places. Damian reports that the median amount spent is $84. Explain briefly why Damian's report could be correct, right? So Damian has called a figure, right? And he said the median amount, A, by the way, median means middle number. Let me put a note on that one time because I'm feeling like a lot of people watching this like, it's the first time I'm coming back to them. Kiana, first time they're coming back there. So median, let's write the notes there, please. Median means, not me, I don't want to use the word median means because we don't have the word mean above. Median refers to the middle number. All right? By the way, I'll write it right here from above. Mean is an average of the data. Right? I didn't write it above, but just write it here one time. It's a note, right? So median refers to the middle number. Mean is an average of the data, right? So we're dealing with median now. Now there's a formula to find the median position, right? And that formula would be n plus 1 divided by 2, okay? So this will give you the median position. So it's like TH, it'll be that or whatever position, right? Okay, I'm gonna put where n is the total. Right? So we go in. So if I want the median position, while you're writing this, we could just build this out one time, right? So median position would actually be equal to n, which in this case was 100 plus 1 divided by 2. So we're actually looking for 100 plus 1 will be what? 101? 101 divided by 2 will give me what? 50.5. So we're looking for the 50.5 student, all right? Okay? I'll show you how we finding this, okay? 50.5 student, or if you want to remember when you was doing these kind of questions. So watch it there. Write this. Saying it again. This is not the median amount spent. This is the median position. So going up to the So this is the order of the students here. This is the first 7 students. So 7 plus 11 will be what? 18, right? So the first 18 students are in these two ranges here, right? Or these 2 class intervals. Everybody good there? So that means the first 7 students got money between 50 and 60. The next 11 students got between 60 and 70. So you can say the first 18 students got between 50 and 70. That is correct to say? All with me? Right? Now, 18 plus 31 is what? 18 plus 31. 49. Right? So we sure the 50th student is not getting any of these amounts here. Right? Because up to 49 is between 50 and 80. So you're sure that that child, whoever that 50.5 student is, not getting anything between 50 and 80. So basically, where would that child be? In which interval that child is in? And that child is in this interval, because the next 29 students getting between 80 and 90. So is that person, what's the person name? Is Damien correct to say that the median amount spent is probably $84? Because that child is getting between 80 and 90. Some number in between there. So is he correct to say that? Yes, he is. Right? Because we show that after 49 is 50. So 50 to, what this will be, boy? This will be 8, 7. 50 to 78. 50 to 78, getting the 50th student to the 78th student will be getting money between 80 and 90. Right? So is he correct? Yes, he is. Right? Ask all the questions now, because I know everybody can catch that. Is understanding the order. I'm moving this. Ask all the questions. All the questions. So it's like this is the first 49 students, right? Okay? Up to the 49th student getting this set of money. That's the best way to look at it. But we're looking for the 50.5 student, which is going to be in the next class interval between 80 and 90. So Damien is correct. So I can write that now. Damien is correct because the 50.5 position is in the class interval 80 less than X less than or equal to 90. All right. The two-way contingency table below gives information on the mode of transport of two schools, for 100 students, right? So you have those who walked, those who cycled, those who drove, and then you have your totals, right? So going across supposed to add up to 48, right? This is dog food, right? So let me see what they want us to complete the missing values. This is dog food, eh? Coming down supposed to add up to 100. So what number coming here? Food. What number coming here? 9, how much? You sure? 48 plus 19 is 100. Coming down would add up 52. Everybody good there? Everybody good there? Right? Now, coming down here, this is the total. So this is how the two-way works, right? So coming down supposed to add up to 23. So what will be here? 8 Right? Let me see. Going across supposed to add up to 40. So what coming here? 19. Coming down would add up to what? 19 and 18 is what? 37. Food. 2 marks in the bag.
No, mark.
Right?
1 mark.
2 marks.
No. That's 2 questions is one for each.
No, brother. This is a different mark here.
Alright.
Right?
I don't marks.
Huh?
I don't mark.
Yeah. Right. There we go. 2 marks to complete all this is 4. I've seen 4 digits, so they're probably given a mark for, yeah, half. Yeah, correct. There you go. A student is selected at random. What is the probability that he or she was being driven to school on that day, right? So a student is selected at random. What's the probability that he or she was being driven to school on that day? So how many students are being driven on that day? Everybody good there? With 40, let me put a formula for you all, right? Probability. So the probability, right? The probability would be the number of desired outcomes, right? Number of desired outcomes. And then we're going to divide that by the number of possible outcomes. Of possible outcomes. Right? So if we're talking about the probability that he or she was driven to school on that day, right? He or she, how many students were driven to school that day? For everybody seen that? Everybody able to read this table online? You're able to read this table? See that 40
Yes,
students were driven to school that day? So the desired outcome would be the 40 students, right? So your probability, so the probability, and we can just put in brackets like put driven, right? Probability of students, well, for the number of students driven, right? So there you go. 40 over what is the total possible outcomes or the total amount of students it had in all? 100. So it'll be 40 over 100. This is the probability that a student was driven on that day. Let's break it down now. What we can say here, zeros cancel. 2 into 4 is? 2 into 10 is? So my answer here will be 2/5. Right? You can leave it just like that. 2 over 5. 2/5 is your probability. On pause. One of the girls is selected at random. So are we dealing with all the students now, or are we dealing with the girls alone?
No.
Girls, right? So let me see how much girls it have. Girls will be 52 girls. So that is whatever we want to find the probability of, it will be over 52. Because 52 will be the total possible outcomes. Right? So there we go. What is the probability that she did not cycle to school? So the probability that she did not cycle, right? This will be, wherever it is over 52. Because I know it's 52 girls. How many girls did not cycle? Scrolling up to see, right? Dimitri, how much girls didn't cycle here? How many girls did not cycle? What we adding? Huh?
8.6.
You see that? Dimitri? 8 girls walk. How much girls were driven? So I need to have 8 plus 26, right? So it'll be 8 plus 26 over 52, which is what? What are we breaking down that to be? Well, it will be 34 over 52. 2 into 34 is what? 17. And 2 into 52 is 26. So this probability will be 17 over 26. Copy. Pause. Farmer Brown makes troughs to feed his farm animals using wood that is 5 centimeters thick. So you're seeing this thickness going wrong here, Dimitri? Look in Dimitri. I realize I like the drift. Look in here, Dimitri. Watch it here. Oh, let's see the wood. How thick the wood is? 5 centimeters thick. Everybody good there? Right. As shown in the diagram below, the troughs are rectangular base, right? Open at the top. So on top have nothing, right? There's nothing on top here. And have external dimensions of 300. So you see 300 here, 190 here, and 160 here. Now composure is everything, right? Know that we have to account for thickness. Okay? We have to account for thickness. So there we go. Show by calculation that the internal capacity, which is the internal volume of the trough, is 8,091,000, right? Let's see if we could figure out what the internal length is, what the internal width is. Hey, lock in, right? Internal length, internal length, internal width, and internal height, right? So let's look. Somebody trying to come in, hold on. Right. What will be the internal length, which will be the distance? I put it up here. The distance from here to here. Who could tell me? If the external length is 300, what that internal length would be?
290, sir.
395? 295?
290.
290. Very good, Nia. Right? Who does see why it's 290? So watch it. From here to here is 300, right? But we have a 5 centimeter piece on this side and a 5 centimeter piece on this side. So once you want that internal length, you have to minus the two 5 centimeter pieces. Right? So this internal length will actually be, so let me write it here. Internal length would be equal to 300 minus 5 plus 5. I put 5 plus 5, so everybody know I get the 10 from, and you'll get 290 centimeters. Everybody good there? Right? Let me deal with the internal width. We do the same thing here, Dimitri. For the internal width, if the outside is 190 and I want the distance from here going up to here, you think I should do the same thing minus the same 10 centimeters? All right, so watch it here, right? This here is the thickness. When I look at the outside, so it's like I have a piece of, okay, look at this line here, right? Look at this line. Okay? If I have the external length is 190, everybody seen that? And then I seen that you have a piece of wood that is 5 centimeters thick here, and then on this side it's 5 centimeters thick also. And I want the distance from here to here, Dimitri. Okay? This is 5 and this is 5. How would I find the internal length? And I'll have to minus 5 plus 5, which is 10. Right? So the internal width is going to be equal to the 190 minus 5 plus 5. Everybody seen that? Which is what? 180 centimeters. Right? Now the secret in the internal height is they said that, where they said it here, boy, it's open at the top. Meaning there's no thickness at the top. Okay? There is no thickness at the top. So if I want the internal height, what am I minusing? Am I minusing same 10? 5. We just consider the thickness at the bottom because there's no lid on top, right? So we go in. Oh, we're right here. Internal height would be 160 minus 5. Everybody good there? 160 minus 5, which is 155. Who is not clear on how I get these things now? Remember, there's no lid. Johan, you good here?
It's just the I know you see the other minus the 5.
All right, watch it. This thickness here, right? I'll go and shoot it again. I'll put it in red. All right. So you see on the inside here, right? This piece of wood come into here, all right? That's the thickness of the wood, okay? And then there's a next 5 centimeter thickness on this side. You see that there? I don't know why that arrow come there, but that's it there. Okay? So if I want the internal length, what's your different? Right.
Basically, the outside will be more than the inside.
Yeah, the inside will be less.
Yeah.
It's like if I had something physically to show you all. Think of any box you have, a wooden box, right? Look at a cell phone case, right? This cell phone case, right? I don't know if online can see it, but a cell phone case, the length on the outside here would not be the length on the inside because it have a thickness, right? So you have to minus the width of this thickness here from the length of the cell phone case, right? It's not the same. This length here would not be the length on the outside. Okay? Everybody see that? It's just like this because it have no lid. They say it have no lid. So there's nothing on top. So even for the bottom, and this base here have a thickness. So if I want the height here, so the height where I drop the pen in here would not be the height on the outside because you have to account for the thickness. Everybody cool there? Right? So, go ahead, Andrew.
So you can explain how you get the height again.
Right. So, Andrew, look the same cell phone case I'm talking about, right? The cell phone have a thickness underneath, right? But it's an open lid. So, the height of the cell phone on the inside, the cell phone case, is not the height on the outside. Okay, Andrew? So you have to minus the thickness of the bottom alone because there's no lid on top. There's an opening on the top. You hear me, Andrew?
Yes, sir.
So that's why you're only minusing 5. You're not minusing 10. You're just minusing 5. Everybody cool there? Look, I could show it here. Watch. Arrow from here to here. Right? From here to here is what would be 290 centimeters. Everybody good there? And same thing on this side. It have a thickness here. Right? Same thickness here and thickness here. Right? Trying to get as straight as possible. Hold on. Right, boom. Right, so on the inside here, would be 100 and what here was 180 centimeters, right? Everybody seen that? And then the height now, so there's only a thickness underneath. Let me see if I can show that below here. So there's only a thickness underneath there. So that's why it's only 160 minus 5 centimeters and not 10. Right? So let me multiply it now. What is the volume of a cuboid? Volume of cuboid, length by width by height. Excellent. Is length by width by height. Now, very important point to note here. This is the internal volume. So put the word internal. Right? Internal. Internal. Am I right? Tell them more. Coming this way. This is internal volume. All right. So there we go. What's the internal length? Remind me, what's the internal length? 290 multiplied by the internal width. 180 multiplied by the internal height, which is 155. What we getting here when we multiply these guys? Work it out.
Any answer?
You get any answer? So this will be, what says 8 million what?
8,091.
And since this is volume, this will be what? Centimeters? Boom, bang. Right? Right, let me go. Calculate the volume of wood needed to make the chuff, right? So the volume of the wood needed would be the thickness. You see this part that is in gray? That volume and the underneath thickness also will be what we're looking for. So who could take a guess on how we could find the volume of the thickness? We have the internal volume. Where do you think we could find? I give you all a hint. We had a minus. There's something at a minus. You have to find the what? What we'll call the external volume. Right? Hey, bro. All right?
I think you're right.
Yeah, there we go. So, what is the external length? What is the external width? 190. And then the external height is 160. Okay? So we go in. First things first, we need to find the external. Put the word external, eh? External volume would be equal to 300 multiplied by 190 multiplied by 160. What's the external volume? What again there? 120? Right? So the volume of the thickness would be equal to the 9,120,000 minus the 8 million and 8 million and what? 91. What's the volume of the thickness? This is centimeters cube, eh? What's the volume of the thickness? 1029. One 1,029,000 centimeters cube. All right. I don't know, somebody get 3 marks to that. I a little bit of working for 3. Right. So Farmer Brown must paint the internal surface of the trough, right? You all remember the internal dimensions, right? We have it above. So you must paint the internal surface of the trough. So that'll be what? 4 sides. 4 sides and the base. Remember, don't forget the base. Right? You see in the 3D figure? I find you looking confused. You understand? In the 3D figure? So is the internal surfaces and then the base would be the internal surface of the trough, right? So let me see what Farmer Brown is saying. So given that 1 gallon of paint can paint approximately 280,000 centimeters squared of surface, determine the total amount of paint in liters that is needed to paint the internal surface of the trough. First things first, let us find the area of the surface on the inside, right? You all know how to find area, right? How much rectangles we have here? How much rectangles we need to find the area of? Let's see if you can visualize it. We inside the box, eh? 5. 5, right? You all seen it? 1. So 1 on the inside here, and then the one on this side, well, behind this wall here will be the same thing, right? Everybody agrees? Then you have this one on this side, and then you have another one behind this wall here. So that's 4, and then you have the base. Don't forget the base, right? So let me work. This internal surface will be 290 by what? What's the height? 290 by 155. So let me go. So we're going to find, all right, now all these surfaces one time, right? So this will be internal surface area. So what are we going to do this, right? I have what it was by 190 multiplied by 155. Cool? It's two rectangles like that. So I can put multiply by 2 one time. Everybody get there? Or you can put the 2 in front. Anyhow you want to put it. Okay? I put the 2 in front. I don't like how it looking in the back there. What's another surface? Plus, what's the surface on the side here? 180 by 155. Everybody agrees? Yeah, I now realize it's 290. I put 190. This is the next reason why you have to always be checking your figures, eh? It's 290. Dimitri, you see that? You have 2 more rectangles on this side. I'm gonna go up. You have 2 more rectangles on this side, well, on the inside on this side, and well, this one on the inside here. So that'll be 180 by 155. So there we go. It's 2 of that, right? 2 by 180 by 155. And then the last one, which is the base. How we find the base? What's the dimensions of the base? 290 by 180. That's the base on the inside, right? 290 by 180 plus 290 by 180. So give me my internal surface area here, please. How much centimeters squared? Nobody will call that? Dimitri, where you get it? So we have 197,900 is what you get centimeters squared, right? Now, they said that 1 gallon of paint covering this. So would 1 gallon be too much? If a gallon of paint will cover $280,000, and 1 gallon will be too much because I only need to cover 197,900. So, in order to find out what fraction of a gallon I need, right? So, I'll put fraction because it's a fraction. Fraction of gallon needed. Right? So, this will be equal to 197,900 all over 280,000. And I can actually, what I wanted in liters, right? So I could multiply it by 3.79 one time because they said 1 gallon is 3.79 liters, right? So multiply this and tell me how much liters would be needed. What again there?
2.69 liters.
2.69
liters.
2.69 liters. Somebody second this. Somebody had a second this. 2.69. What after the 9, big brother?
09. That's after round off.
0.678.
Right.
So I got a.
Right. Big up. Right. So that's how much liters we need, right?
0.668.
People getting 2.678. 2.68. Check over that.
So, well, if you round it off from before, the way I work it, if you
you round off this.
Well, yeah, I simplify it first and then multiply it. If you round it off to 3 decimal points, I think you could get that too.
Yeah, you get the same thing. Boy, a pause. Right. So this is the 4th figure here, right? So the number of lines L in each shape and the perimeter P of the shape follow a pattern. Study the pattern of numbers in each row of the table below and answer the question that follows, right? So let's go. How much is this, the number of lines going up by? How much is it going up by? 5. Everybody seen that? Dog food, right? How much would my perimeter be going up by? Right? So it's like plus 5, and plus 3, right? So it's like, you know, whatever your formula is down here is like plus 5 plus 3. Everybody good there? Right? Okay? So, but it's not any formula here. I just shown you that. Plus 5 plus 3. Right. So there you go. So that 5 now, how do we engage this number in order to get this 6? 5 by 1 plus 6. Sorry, 5 by 1 plus 1 will give us 6. Everybody seen that? Let me test it for the next one. 5 by 2. 10 plus 1 is? So could we safely say that the formula for here, well, it's the same 5 we're using, the 5. 5 by n plus 1. Could we all agree? That's the formula, right? We go in here now, 3. Then we do 3 by 1 plus what? Will give us 5. 3 by 1 is 3. 3 plus what will give us 5? 2. Try it for the second one. 3 2s are 6. 6 plus 2 is? So could that work? So 3 by n plus 2. That's my formulas. So let's work now. We're going to work out this, right? So if n, this is your n column. If n is 5, 5 by 5 is? Let me write it here. 5 by 5 is what? 25 plus 1 is?
26.
Here we go. 5 by, what is n? N is 5. No, sorry, 3. 3, not 5 again. 3 by 5 is? 15 plus 2 is? Proper thing. Everybody good there? Right? We're coming back here now. Now here, you actually have to form an equation, right? So this column here they give us is actually 5n. 5n plus 1 is equal to 66. How we solving this? What's the first thing we had to fling on the right? Minus the 1. So 5n is equal to 66 minus 1. 5n is equal to 65, right? Then what we do with the 5 when we carry it here? N is equal to 65 divided by 5, which gives me what? 65 divided by 5? 13. So 13 is n. Let me work this one now. 3 by 13 plus 2 would give me 3 by 13 is what? 39? 39 plus 2 is?
41.
Everybody good there? Dimitri, you good there? You understand these pattern questions? Now you all realize plenty of these things that might make sense right, you know? Imagine if all I had to go and write down this whole table now. It will take too long. It will have lines. So the difference between the number of lines and the perimeter of any figure n, right? So difference, they said call it d. So what's the equation, not the equation, the expression for the number of lines? What's the expression for that? At the bottom there. What's the expression for the number of lines? 5n plus 1. Difference means to what by? Minus. 5n plus 1 minus, now whatever come in here now coming in a bracket. So there we go. What would be the perimeter? What is the perimeter represented by? 3n plus 2. But we minusing that in brackets. 3n plus 2. Right? So what does that mean I'm doing with this 1 here? 1 is understood in front here, right? So negative 1 multiplied by 3n and negative 1 multiplied by 2, right? So let's go. 5n plus 1. Negative 1 by 3n will give me negative 3n. Negative 1 by 2 would give me negative 2. Proper thing. What's the only thing that could work out here? 5n minus 3n. You could only add or subtract like terms. Plus 1 and then minus 2. What would my answer be here? minus 1. 1 minus 2 is negative 1. Right? You all want to write? Let me see what's going on here. Marla buys 2 types of mobile phones, B-Flow and C-Flex, from a company to retail. One B-Flow mobile phone costs $60, while one C-Flex costs $80. She buys X number of B-Flow phones and Y number of C-Flex phones. Marla must not spend more than $1,200, right? Write an inequality to represent this information. Let me hear all ideas. Online, let me hear all you. Who did linear programming before? Yeah, just remember all my questions on the worksheets come from past papers. I would never do a worksheet and it's not past paper questions. So let's go. Marla must not spend more than $1,200, right? So how much? Right, if it's okay, let me start there. We know it's less than or equal to 1,200, right? We know that. Okay, now what is less than or equal to? Let me deal with B-Flow. How much dollars for one B-Flow phone? 60. And what represents the number of B-Flow phones? No, B-Flow will be X plus how much? What is the cost of C-Flex? 80. So it will be plus 80 Y is less than or equal to $1,200 because you have 1,200 in hand, right? So you cannot spend more than 1,200. If you have 2 B-Flow phones, right, it will be like 60 by 2 plus, let me say you have 10 C-Flex plus 80 by 10. And whatever it comes up to must be less than or equal to $1,200. Everybody clear there? Okay, 1 mark in the bag. Right? You can write these. Or you can just stay away from the tables and things, right? In the tables, that might take too long. The number of B-Flow phones must be greater than or equal to the number of C-Flex phones. Write down an inequality in X and Y to show this information. Dog food. Right? The number of B-Flow phones. B-Flow is what? What B-Flow? No. Number. We're not dealing with the price. X is, look, they tell you it here. Greater than or a whole mark CXC just give away here. Y. Cool? Everybody good there? Part 2. So that's it for that. We go into the graph now. Right? So I was actually teaching my Form 1s how to draw these graphs because I realized that drawing graphs just given equations, like students can't wrap their head around it. So I started to teach you some Form 1 now. So what you're going on here? Represent the 2 inequalities on page 22, well, the page before, on the grid shown below. Label as are the region which satisfies both inequalities. So what I'm actually teaching my Form 1s is how to draw a graph just given an equation. They didn't give you nothing else, right? So watch it here. They gave you an inequality for this question, but you can write it as an equation, to draw the graph. So this here, I'm going to write it as 60x plus 80y is equal to 1,200. Cool? And I put the inequality. Watch it. So I have to show, so I wonder if I can make a space here. Yeah. So watch it. I have to show 60x plus 80y equals to 1,200 and well, also x is equal to y, right? On the graph below. Could I reduce this? Well, I could divide everything by here to reduce this. You all know? If I divide here by 20, I divide here by 20, and divide here by 20, I can reduce this equation. So 20 into 60 will give me 3x plus 20 into 80 is equal to 20 into 120 will be what? 60. right? So this is how you draw a graph given an equation. You simply need to find the x-intercept and the y-intercept, right? So you're looking at two situations. You're looking at when x is equal to 0 and when y is equal to 0. Everybody good there? Three more battery in this thing there. I don't know. Yeah, boy. That's how I collect my charge. Right? So let's plug them in now and find two coordinates. This is how you draw a graph, as I said, and you are not given any coordinates. Right? So let me go. When x is 0, right? When x is 0, so we're going to plug in x as 0 here. So it'll be 3 by 0 plus 4y is equal to 60. So you need to find y, right? Everybody with me? 3 by 0 is what? 0, boom, bang. Right. So this will be 0, right? So 0 plus 4y will just be 4y is equal to 60. What do I need to do with this 4? Y, excellent. Y is equal to 60 divided by 4. Y is equal to 15. Right? So this coordinate here is two separate working. This is one working here. This would be my y-intercept, right? This coordinate would be x being 0 and y is 15. That's one coordinate I could plot. Right? Next situation, right? Y is 0. Let's look. This is the equation above here. So it'll be 3x plus 4 by 0 is equal to 60. 4 by 0 is 0. 3x plus 0 is 3x. 3x is equal to 60. What do I do with this 3 when I carry it here? X is equal to 60 divided by 3. X is equal to 20. So what would this coordinate be? What's the value of x? 20, and the value of y is 0. This here is my x-intercept. Cool? My x-intercept. Are we clear? So we're going to unplug this bad boy now. For the line x is equal to y, right? I write it up here. Let's write it. Let me put a note here. For x is equal to y, slip. 4:30 earlier, and we on 3 questions. For x is equal to y, right? The value of x is equal to the value of y for all points on this line. All right? Okay? So for the line x is equal to y, you could use 1, 1, you could use 7, 7, you could use any 2 points, the coordinates of any 2 points, and let's draw the line through it, right? So we're going now. All ready? Anybody want to copy this up here? We'll pause the record. So corner your axis, and the counting in is 1 centimeter to 1 unit. So just like 1, 2, 3. Wait. 1, 2, 3, 5. Wait, is every 4 centimeters is 5 units, right? Every 4 centimeters is 5 units. So if we take this will be 20 divided by 5. So every 4 small strokes is 1. So like right here, watch it. So like right here would be 1. Right here would be, we go 1, 2, 3, 4. Right here would be 2. But you don't need to put in this. There's no every 4 centimeters is 5 units. Every 4 centimeters is 5 units. So draw it quickly. Okay, so let's first plot the line, which is 3x plus 4y is equal to 0. So these are the points you plotted. 0 on the x, 15 on the y, right? So let's locate that. 0 on the x, 15 on the y. Look, that bad boy is actually on the y-axis. We also call it the y-intercept. That is here. Everybody good there? First point. Then my second point would be 20 on the x, 0 on the y. So we on the y-axis. 20 on the x, 0 on the y. We quite here. Everybody good there? Let's connect the dots. All right, so we go in. So we here. Connect these dots, right? Well, I have to use a ruler. I have autocorrect.
Oh.
I'm going to shift a little bit, but gotta draw it over now. Now, catching it right there. All right, let me go. Everybody good there? Label your graph. This graph would be 3x plus 4y is equal to 60. Do that for me, please. Do that for me, please. The line, while you're doing that, the line y is equal to x is very simple. Like I could do 5, 5, right? Look, 5, 5 here. Bang. Right? You have 0, 0, 0, 0s here. That's on the x is equal to y-axis. Then you could even plot 10, 10. Where 10, 10 is by 10, 10. Here. Everybody good there? Let's connect the dots. And then you keep going, keep going up. Could complete way, boy. Right. You could go until the end of the page. Right? What's the label for this graph again? What is this line? X is equal to y.
Sir,
Right?
I have a question.
Right, big brother?
What does mean when they say to break the scale? in
To
our
break
graph?
the scale?
Yeah. What do I
first-
mean by that?
First time I hear I never heard that before. Break the scale, it probably mean to
Like
show it.
you're not starting at you're in like 0. You're starting at like another number, like 5 or something.
Right, that's when we're
Oh.
doing statistics. When we're doing statistics, we do that, but I don't call it break the scale. Yeah, that's not starting from 0. Yeah, that's put like a lightning. Yeah, it's put like a lightning strike or like a heart monitor. It's go fup, 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 fup. Right? Right, Christian? You see that at the bottom
Yes,
here?
sir.
Yeah.
Yes, sir.
But we should encounter it somewhere in statistics. Right. Everybody good there? So, what's something? We have x is equal to y. We have 3x plus y equals to 60. Representing two inequalities on the grid, right? Now, all we did is we drew the lines. We did not represent the inequalities. We did not figure out where the region is. So the region we want to show, I want to go back up here because I want to show you all that this inequality is actually, so if I divide here by 20, divide here by 20, divide here by 20, this is the same thing as what we have below, which is 3x plus 4y is less than or equal to 60, right? So 3x plus 4y is less than or equal to 60 to show that on less than or equal to. So we know we under the line, okay? So my region is somewhere, watch it there. My region is somewhere under here. I join some light lines because I have to erase one of them, right? Somewhere under here, but it's where the two clash, right? And the next line I believe is x is greater than or equal to y, right? Now, where x is greater than or equal to y will actually be on the right of the line x is equal to y. So we're looking for somewhere on this side, right? On this side. So where would the two regions be clashing? Would they be clashing here? Like call here A. Would it be clashing in A? Would it be clashing in B? Or would it be clashing in C? Where the two regions clashing? B. So what you are going to do now? I just did that to show you all, right? I reason this, right? I also reason this because they said to call my region R, right? So the region is R, right? Yes, they did say R. So the region that satisfies both inequalities would be this region here. Right? This is the region. Okay, and we'll call it R. They didn't say to shade it, I just shade it. Okay, this is R. Talk to me, you all catch it? You all catch it? We catch it? So, the total number of mobile phones is represented by x plus y, total number of mobile phones, right? According to the graph, what is the largest possible value of x plus y? Now, to find the largest possible value of x plus y, we have to examine the vertices of the region, right? So watch it. We examine, this is one vertex here, right? This is 0, 0. This vertex here, which is our next point, would be 20, 0. And this vertex up here would be, this one tricky, right? So we counted. Every 4 small boxes is 1. So this will be 6, 7, 8, 9. Right? So this here actually lines us with, this is 8. So here will be 8.5. For me, it's looking like 8.5 and 8.5 on this side. Yeah, looking like the same thing, right? Well, it would be the same thing because we're on the line y is equal to x. So if it line up with 8.5 here, it would line up with 8.5 on the next column, on the next axis, sorry, right? So these are the 4 vertices of the region. Which one will be the largest possible value for the x value plus the y value, or x plus y? So the regions, the coordinates we are examining would be 0, 0, definitely can work, right? Definitely can work. 20, 0, and 8.5, 8.5. Right? Which one has the largest value for x plus y? Would it be the 20 plus 0 or the 8.5 plus the 8.5? 20 plus 0 would be equal to 8.5 plus 8.5 is 17. So therefore, 20, 0 is the largest possible value. Right? Guys, I know we only have 10 minutes, but I'm not leaving our question unfinished. So we finishing this question. We still have part B to do. The table below shows pairs of values for the function y is equal to x squared plus x minus 4, right? This is a quadratic, by the way. So these are all my x values, these are my y values. On the grid, plot the remaining 4 points and draw the graph of the function y is equal to x squared plus x minus 4 for negative 4 less than or equal to x less than or equal to 3, right? So we're going to recreate this and we're going to draw the graph, right? So let's go. Recreate this first. So points to note, on the x-axis, they're doing 2 centimeters to 1 unit. Everybody seen that? And on the y-axis, they're doing 1 centimeter to 1 unit. Realize your y-axis pull to the right a little bit. So shift your y-axis to the right a little. So let's... Right, so remaining points we have to plot. These points, we got them from the graph up here, right? 0, comma, -4, 1, comma, -2, 2, comma, 2 is way up here, 2, comma, 2, then 3, comma, 8, right? Let me see what the instructions would be. Right, plot the remaining 4 points and draw the graph for the function, right? So once you have a quadratic function, my children, it will always be a curve, right? This is actually a minimum curve, right? Once it's a U, it's a minimum curve. So let me go. We're going to draw a curve. Insert. All right, curve. So we go in. Boom. Bang. 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 Going up now. Bang. Going up. Right. Label your graph. This graph would be y. Whatever the quadratic is what your label will be. Y is equal to, I believe it's x squared. X squared plus x. Let me check. When you see that graph, -4. -4. That is the label for my graph. Make sure you're looking good, sir. Annalise, you're looking good, sir? Desha, talk to me. Kiana, talk to me. Yeah? What's the name again, bro? Isaiah, right. I have plenty of Isaiahs in my class, buddy. Yeah, about 4. Elliot, mom, we ain't done it, brother. We come here to win, bro. We ain't come here to lose, We have one more part to do, brother. Let you go. Or minimum. Let me give you a few things here. So first things first, the maximum or minimum, write this down. This is our note. Note. The maximum or minimum point is given by -h, comma, k. Right? Then your maximum or minimum value of the function is the value of k, right? So these two coordinates here, -h, comma, k, would actually be the lowest value. So we have to try and figure out what's the lowest value on this curve, right? So I'm just scrolling up for a minute here. I'll come back for you all to finish writing. So the lowest value here will be 1, this point here is what we're looking at, right? So this coordinate here would actually be negative. This is -1/2, right? -1/2 is here. Yeah, -1/2. So this is your minimum point, right? Would be -1/2, comma, here will be -4.2. What?
That's 1 square, right? So I mean,
What 1 square are you talking about?
Like one little square.
Yeah. So every 1 square is 2 because watch it. If he has 1.1, 1.2, 1.3, 1.4, and then we jump into 2, It'll be 1.2, 1.4, 1.6, 1.8, and then 2. Right? So it'll be 4.2. Everybody good there? See for again, the same thing on other graph. See for the graph lining up. We lining up? Right? This is the minimum point. So what if I say is negative h comma k, right? This simply means that k is equal to negative 4.2, right? So it's like negative h is equal to negative a half. So if you're looking for the value of h will be positive a half. K is negative 4.2. So that is your maximum value. Right? So K would be equal to 4.2. All right? Everybody good there? Is negative 4.2, sorry. Negative 4.2. Right? Using a ruler, draw the axis of symmetry on the graph, right? The axis of symmetry, let me write a note. Note. There you go, Dimitri. A little 5 minutes and go kill we. Note. Axis of symmetry is a line that cuts the graph into two equal parts, right? That axis of symmetry, if it's a U, and I want to cut the U into two equal parts, mirrored, I should put two equal parts. I'll just put mirrored here. Okay? So watch it. If I have to cut this into two equal parts, you have one line of symmetry in this curve. Where that one line of symmetry will be? Will it be something going so or something coming so? Top to bottom. There we go. Starting here, boom to the bang. This here will be my axis of symmetry. Party done. Axis of symmetry. And it's over. So that's question June 2021, questions 5 to 8. All right?